My name is Slawomir Gabrys. I would like to tell you about new motion in endodontics. The most important stage of each endodontic treatment is widening of canal system to make space for irrigants and future obturation. Since 1990s, we have used files made from nitrile alloys, which were fixed in endodontic motors. Mechanical preparation is not only faster, but also more efficient. Manufacturers for the last 25 years have tried to introduce new technologies for the production of mechanical endodontic files. For example, heat treatment of nitrile alloy to improve flexibility of the files and resistance to breaking in the canal. Also, the type of movement which performs endodontic motor with the file in the canal has been modified. First, we only had a rotation motion, so a file constantly rotated 360 degrees in a canal. Since 2008, we can also use a reciprocation motion in preparation of the canals. It was the time when Dr. Jarrett described technique of the shaping canals with a motion other than rotation. Reciprocation motion is when a file performs alternately partial clockwise rotation and partial counterclockwise rotation. This partial rotation is referred to in degrees. For example, 980 degrees clockwise and 90 degrees counterclockwise, which mean that the file alternately moves half of the rotation clockwise and then quarter of the rotation counterclockwise. So for the file to make a full rotation, 360 degrees, it needs 4 cycles clockwise and counterclockwise. Reciprocation motion has some advantages over the rotation motion. First, a file making the reciprocation motion is more resistant to cyclic fatigue, so it can work longer in a curved canal before it breaks. Secondly, during a reciprocation, it takes longer before a file performs a full rotation. So before it crosses the torsional resistance of the file. The reciprocation motion also reduces the time needed for canal preparation. Next advantage of reciprocation is that we need less time for preparing canal. However, reciprocation motion also has its disadvantages. Firstly, in reciprocation, we may have an increased transportation of debris toward the apex during the counterclockwise movement. This can result in increased pain after endodontic treatment. Secondly, in literature, we can find information about an increased number of dentine microcracks after using reciprocal systems, especially one-file systems. That's why Malta company patented a new type of motion in about 2016. The so-called OTR, optimal torque reverse. It is combined motion because it combines a rotary motion with reciprocation motion. To be more precise, it is rotation with reciprocation which activates when it is necessary for work safety. In OTR motion, and the motor decides how the file moves inside the canal, whether it rotates or performs reciprocation motion. When we insert a file into a canal, it rotates 360 degrees clockwise. When the force acting on the file is too big, the file reverse rotation in a counterclockwise direction by 90 degrees, and then continuous rotation in the clockwise cutting direction for 180 degrees. During this half rotation in the cutting direction, the sensors of the handpiece calculate the force acting on the file. If the force is too big, the file will automatically reverse rotation again, 90 degrees in counterclockwise direction. And then it will rotate in the clockwise direction for 180 degrees, and the motor will calculate the acting force again. So if the force acting on the file is constantly too big, the file performs a reciprocation motion 180 degrees clockwise and 90 degrees counterclockwise. If the force acting on the file is small, the file constantly rotates in the clockwise direction. So the endodontic motor calculates force which is necessary to perform a half rotation in the cutting direction, and it decides whether to reverse rotation 90 degrees or continue it in a cutting direction. A common question is whether to OTR is different to auto reverse. Well, it is very different. With auto reverse, when a file reaches the limit of the set torque, it is stopped, and then reverse rotation is activated. We need to remove the file quickly from the canal or it will break. OTR doesn't stop the work of the file in the canal, but it starts a new, safer reciprocation motion, and we can continue preparation. So OTR allows for faster and safer canal preparation. Endomotor endosser provider, which I am holding, is the motor which uses OTR motion. It was produced by Morita company. We can use it with a continuous rotation or with OTR motion. In OTR, we can set 5 levels of torque limit: 0.2, 0.4, 0.6, 0.8 and 1 Newton centimeter. Normally, in my work, I set the OTR activation at 0.6 Newton centimeter. If the canal is more complicated, I reduce it to 0.4 Newton centimeter. When we have to deal with extremely difficult canals, for example, double curvatures, we can reduce it to 0.2 Newton centimeter. The lower the level of torque limit we set, the more often the file works in reciprocation movement. So at the lowest setting, we basically use reciprocation motion with very few rotation. So OTR we can count an intelligent rotation which activates reciprocation when we do not realize that too great force is acting on the file. Endomotor does it for us. It's good to know that with OTR motion we can work with right-cutting files, so basically with most of files on the market, like M2 ProTaper, Endostar E3 Azure. OTR motion we cannot work with left-cutting files. On the market we have two kinds of these files, reciproc and wave 1. This endomotor provider can be connected with apex locator called Endostar Navigator, so that we can work with the knowledge what is the position of the file inside the canal. Thank you very much for your attention. Have safe and efficient work.